share my screen. So Pooja is going to give you first a quick poll, and then I'm going to start my session. Okay, great. So thank you everyone for sharing your feedback. I think this is going to be somehow our last, not last, but like the last session in terms of like giving you new information and new knowledge in programming. And then after that, you're going to have I think a nice game or a quiz thing next week. So hello again, everyone. So we're going just to get it started. Okay. So today's session is going like to be like talking about like a feature in this Ignite theme, which is called like collision, and we talk about like how we can detect if two objects in our window collide each other. So first, we're going to talk about like another application of software engineering, and then we're going to talk about like the collision, and then after that, we'll see how we can use image in our games, right? So because so far we use like the rectangles, circles, right? But then we will see that we can actually, for example, use some sort of image, like import images for our program. So this is like one of like the cool application of software engineering. So like there are some studies that show that like dog can detect like diseases by smell, right? Like up to like with like 99% accuracy. And then there's this machine learning thing that we can use to teach a computer how to understand and detect like follow like the same behavior. So for example, a team in MIT like did that, and then they also created like a model that can beat like the sensitivity of like the dog. And you need like to know some sort of like programming and like some sort of like knowledge in software in order to implement that idea or concept, right? Because otherwise, even if you know how to do that, you need like a way to tell it to the computer. So that is where like the programming comes in. Okay, cool. So we are going to do a quick review on function. So we talked about like the function last session. The function in general have like two parts. So like by two parts, I mean like the first part is like when you say like def, and then my function whatever. So you try to define like your function, right? So you say like def and then my function, and then the parameters is optional. You can have it or you don't have it. So it's up to the up to your program, right? And then you have like the function body, right? And then in the function body, sometimes you may have return, right? Sometimes you don't. So again, this return value is optional, right? But if you don't use the return value, you cannot use the output of that function, right? You can print something or you can show something, but you cannot use that returned output later. So in order to use that value, you need to return like the particular value that you're looking for, and then store it in another variable and then use it later. So we talked about all of these before. So here, for example, like this circle that we used before, right? So we have like the circle, we have like the x coordinate, y coordinate, and the diameter, right? So it is important to note that this is just a function. So the circle is a function that is already written by some people in the Ignite team, right? And you just see like the surface, like the circle, and then you just call it, and then you just provide some three numbers like x, y, d, and that's it. Then you can create a circle. But what's happening behind the scene is that that circle is actually like a function that gets three information, like three values, like x, y, d, as the x coordinate, y coordinate, and the diameter. And then it creates a shape, like for example, in this case, circle, right? And return it and bring it to the window. So that's like how you see like the circle. And also we talk about like the sort of results. So for example, here you can say 2 plus 2, right? It works, right? Even if you don't assign it to x, it still works, right? But if you want to print, for example, that output, you need to store it in x and then print it. Perfect. So for example, here you can see that this function 2 plus 2 is just a simple function, right? You just add 2 together, and it doesn't have parameter, right? Because as I said before, it's optional. And then since you want to use the output later, so that's what you do, return answer, right? And then when the function is called, the answer is what is returned. So in this case, it's 4. So 4 is going to be assigned to x. X is 4. 4 plus 1 is 5. So that's why it prints 5. Okay. So now we want to talk about like the collision. So like the idea is this, right? You want like to see if two objects in a window, right, like make a contact with each other, right? If they, for example, in this case, you can see that like in the middle of like the window, when like the red squares move, here there is a collision, right? The idea is like, how can we detect that? So to understand that, we need to first understand like the bounding box. So what is bounding box? Bounding box represent like the edge of the shape, right? So this case is really simple and easy to understand, because the rectangle is like the bounding box of the rectangle is exactly the same as like the rectangle, right? But that is not always the case. So for example, maybe if you have like a circle, right? You can of course have a bounding circle, but in this case, but in this function, like the bounding box, it still creates a bounding rectangle around that circle, right? So the whole idea is that whatever shape that you like, right, you can put some sort of like a bounding box around it, right? You can say that, okay, so my shape is inside this box. So this is like what so for example, my shape is circle, or like even a small image. I put a bounding box around it, and I assume that my image or my object is that bounding box. It's like surrounded by that bounding box. So here, like a simple example. So let's say you have two rectangles, right? 1 and 2. So I mean, it's obvious, right? So this is the picture on the top. There's no collision, but then below you can see like there's a small overlap, and that's why that's why we call it like collision, right? So they somehow meet each other. As I said before, in the rectangle, the idea is simple. If you have a rectangle, the bounding box will be exactly the same. So for example, if you create a rectangle with 0 and 10, which is like the reference point, right, on the top left here, and then you have like the 50 and 30 as like the width and the height, you will have the same size bounding box. So for the bounding box, you again have the 0, 10, and 50 and 30. So like this is like a really easy way to use the bounding box in this type of figure. So like type of shape, like if you have like the rectangle, it's super easy. You just use the same values that you use for the rectangle to create the bounding box. So in general, again, the bounding box, right, it's not a bounding circle, right? It's bounding box. So it's like a rectangle, right? So it needs like the x position, y position, which is like the top left corner of that box, and the width and the height, right? So this is exactly similar to the rectangle, right? So the rectangle creates some sort of like a shape, and you can see it in window, right? In window, but the bounding box is a like object that just stores the information of that boundaries. Right? So what's happening here is that when you use like the bounding box, right? This is like a function, right? So you don't see like what's happening inside that function. But what you need to know is that whatever value that you provide to that bounding box, like the X position, the Y position, the width and height, these four values are stored in bounds, which is like the return output of that bounding box, right? So the whole idea is that you just create four values, and then the bounding box just like the boundaries, and store that in the bounds. For example, in this case, bounds variable. Of course, as I said before, you can use any name, right? You can use, I don't know, like I don't know, Q or book, right? Whatever. But here we use the bounds because it makes more sense to use like a name that deliver the message. That's what we're doing here. Right? So this is like the interesting part. So now let's say you have like two bounds, right? Like this one. I'm going to just go back to the previous slide, like this one. So let's say you have like the 1 and 2. You already like, let's say, define like the boundaries, like the positions and like the width and height of the rectangles, like the boundaries for 1 and 2. And how can you, for example, see if if there's an overlap or not, right? So one simple idea is that like you can have a paper and draw in your paper and say, okay, so this is like this position with this width, with this height. You draw those rectangles and see visually if there is overlap or not, right? So that is like one way. But automatically, if you want like to tell the computer, like if you want like the computer to detect if there's overlap or not, we use the function collider, right? So this is, again, this is like a function that is written and is prepared already for you guys, right? So you don't see what's happening, and we will talk about that shortly, what's happening inside that. But what you need to know is that this function needs two inputs, two parameters, right? So these are the parameters of this function. So you need to provide the boundary for two objects, right? For two things. So the bounds 1 and the bounds 2, right? And then if there is a collision, it says false. If it's not, it says true, right? So for example, let's do it here. So let's say I create like a boundary 1, and I call it, oh gosh, I feel like the function name. What was that? Oops, bounding box. Okay. So I'm going to do bounding box. And then let's say I want to like put it in position 50-50, top left, right, with the width and height of, right? So for the sake of simplicity, I'm using the exact values for the bounds 2. So I'm just saying, okay, so bounds 2 will be the same box. So if they're the same, it means that there is a 100% overlap, right? So of course, if there is even a small overlap, we call it collision, right? But in this case, I don't want to use any other values like this is what's happening. I just want to just use a simple case to show you like how it works. So this is just a same boundary, so they completely overlap each other because they are in this, like exactly the same. So if I do print collided and bounds 1 and bounds 2, let's see what's going to happen. So this collided is a function that detects whether there is a collision, right? So its output is like true or false, like it's like a Boolean value. So if I print it, I should either see true or false. So in this case, I should see true, right? Because there's a collision. So let's print it. Yeah, so you can see true. But what's happening here is that because like the draw function try to like run this function again and again, you see a lot of true. But as I said before, like the idea is that to show you like what's happening here. Perfect. So let me just remove that. Okay, cool. So I'm going just to reset and pass. Okay. So as soon as like we see like if two boundaries or like two bounding boxes like meet each other, right? We say we return true. We say that there is a collision. So quick question one. So this is like a poll, and I'm going just to see what's going to happen here.
I'll close it in about 20 seconds.
Perfect. So I can see like 85% chose option C, which is the correct answer. So don't forget that here, the bounds one and bounds two, there are some sort of like object or variable that stores the position of the rectangle, right? So they are not Boolean values, right? So the collided function is the function that needs two parameters, which is bounds one and bounds two. And this function collided whatever return a Boolean value, right? So in this case, for example, there is a collision, so this collided function returns true. Perfect. So the correct answer is C, which is collided bounds one and bounds two is true. Okay. So now the idea is how can we use like this function, right? So I'll show you like it gives you like a true if you use it, right? But don't forget that the like mostly when you see like a variable is like a Boolean variable, like true or false, it is a really good opportunity for you to use it in a if a statement, right? Because if you have like a condition and you want to see, for example, you want to do something when it becomes true, right? So that is like where the Boolean value comes in, right? So if, for example, you have like this collided function that gives you a Boolean value like true or false, so it should give you a hint that maybe I can use it in a like a if block, right? So you can use it in a condition for the if block. So you can say, okay, I have bounds one, bounds two, and then I want to like do a particular task or a particular thing whenever there is a collision, right? So you can say, okay, if collided bounds one, bounds two, do whatever you like. So for example, says change direction, move object, right? Stop moving, change color, change the size, right? So you can do whatever stuff you like, right? And this gives you some sort of like more flexibility in terms of like creating a new maybe games or a new cool like shapes and like things in your computer. Okay, so this is like one example, right? So here we can see like there are like two objects that they are going towards each other, right? But they are not going to pass each other. So as soon as they touch each other, they touch each other, so they're going to move to the other direction, right? So I have this code here. I'm going to copy it here. Not here. I want us to keep this one later. I want to copy it here. And then we're going just to see, like going through this code to see what's happening, right? So first of all, before even we start anything, we can see that like these objects are moving, right? And then which means that like their positions are changing, right? So if their positions are changing, you know that you should put it outside like the def and then use a global keyword, right? To make them global variables and update them, right? Because otherwise, if you use them directly inside the def draw here, then after each time the draw function run itself again and again, you're going to reset those values, right? So this is just a simple like obvious part, like you put like x whatever, and then you put like some values here, right? And then you want to make sure that like one of them is moving to right, one of them moving to left, which means that like one of them has like a positive speed, the other one has negative speed, right? So the x1 is negative here, but it's up to you. You can choose x1 0, right? You can start right from like the left side of the window, or you can say I'm outside of the window and I'm slowly coming inside. So let's go back to the previous slide and then see. So I mean that it's happening so fast, but you can see that like it takes a while from the red coming from left to right, which means that it's outside of the window, right? So if you provide, for example, x1 0, the red box, it starts exactly from the left side, right? So this part is just what we did before, right? You have like some values, you have some speed, and that's it. So again, you call them global because you want to update them, right, inside the function, right? The background can be anything if you like. You can just put it blue, purple, it doesn't matter for like this part. What we are interested in is this part, if collided. So what's happening here is that the algorithm is going to run again and again, right? So in the beginning, there is no collision, right? So this if block is going to be skipped. So nothing is going to happen here, right? And then you have here, which you are updating the x1 and x2. Sorry, the x1 and x2 based on the speed, right? So for example, for the x1, you are increasing it. For the x2, you are decreasing it because speed 2 is negative. So if you add it, you are actually decreasing the x2, right? So you are trying to push them together. We are trying to move them towards each other, right? So the algorithm is going to run again and again. At some point, when they are really close to each other and they're going to meet each other, this condition becomes true, right? This condition, but by the way, this is like a really long line. So a better way to do this is to do this because my window is small, you cannot see the whole thing, right? So I prefer, because I just do it side by side, my window is side by side right now. I'm going to do it like this. Let me just say that, okay, so I have bounce 1, bounce 2. You don't need to do that because, I mean, that is a temporary variable, right? So you don't need it anywhere else. I mean, you just need it for this collide function. But I just want to do it because you can see what's happening here. So you can see all of this stuff in my screen. Okay, so I just assign them to 2 variables, right? A bounce 1 and bounce 2. And then every time that I update x1 and x2, I created a new bounce because my bounce is moving, right? So I have like new values in bounce 1 and new values for in bounce 2. And I check if there's a collision or not. And if there's a collision, I'm going to reverse like their direction, right? So the speed 1 -1, the speed 2 -1, right? Of course, if you want like to make it like more complicated, you can add another condition that whenever like they collided to the left sides, they can come back again, right? Because if you can see here, so when they meet each other and there's a collision and they move to the right, right? But I mean, this coming back is just an animation, right? But what's happening is that they're not going to come back because when they go to the left, there's no other condition to say that, hey, if you go to the left, please come back again. So let's try it and see what's going to happen. I'm going to do it here. Because my screen was small, you can see. Okay, so let me run it again one more time. Right, so it takes a while. for them to come, but I mean, and then they are just going away, right? But again, if you want like to for them to come back, you can add another if condition to make sure that they are just going just towards each other and then go away and then get towards each other, right? Cool. Okay. So this is just to give you some idea that what's happening inside that function, right? You don't need to understand that to use the function collider, right? This is some sort of like a math behind the scene, right? So the idea is if you have like the information, like the boundaries, like bounds 1 and bounds 2, how can you detect with numbers, not visually speaking? But of course, if you draw them on the paper, you can see if there is a collision or not, right? But the idea is that how can you use those numbers, right, to check if there's a collision or not? So for example, on the top, you can see there is a collision, right? What's happening here is that the L1 is less than R2. So the left one, like the left side of the bounds 1 is less than the right side of the bounds 2. So what's happening here is that if you have this condition and if it is true, that means that your box, that your bounds 1 is on the left side of the bounds 2, right? I'm not talking about collision here. I'm just saying that the bounds 1 is on the left side of the bounds 2. So let's think about this. What happens if, for example, you have, let me see if I can write it here. What's happened if you have something like this? If you have L1, for example, greater than R2, right? So if you have something like this, that means that there's definitely no collision, right? Because if you imagine that the L1 is on the right side of the, if the like the bounds 1, like the box 1 is on the right side of the box 2, and the L1 is bigger than R2, there is no way that there is a collision, right? But if the L1 is less than R2, then you have two conditions. Like you have like to check another thing. So if, for example, L1 is less than R2, and in this case, L2 is sorry. Oops. Let's see. Did I? Oh, okay. I'm just trying to see something. Okay, so this is like the case that I mentioned. Sorry. So if L1 is not less than R2, which means that L1 is bigger than R2, right? It means that there is no collision. Of course, I mean that I don't think you need the second condition, L2 less than R1, right? Because L2 should be already less than L1. Sorry, L2 should be less than R2. That is weird. Okay, I think that like for this one, you just need this condition. Like if there is L1 is not less than R2, which means that L1 is bigger than R2, there is no collision. But for the top one, if L1 is less than R2, then you need to check the other one as well. Like L2 is less than R1 as well, right? By the way, you cannot just check L2 is less than R1. So what's happening here is that if L2 is less than R1, which means that, like for example, if you you take this box 2 and move it just to the left side of my window, right? Very far to the left, right? So in this case, L2 is still less than R1, right? But there's no collision. So you need both of these conditions, L1 less than R2 and L2 less than R1. This is just for those guys who are interested in writing the function collided or something similar themselves, right? But again, you don't have to write it yourself because it's already written for you guys. So you can just use the collided function. But if you are curious and if you want to do it yourself, try it. I mean, it's a good practice. This is again, you can just go through it later because I think that I put a lot of time to this for now, so we are good. Okay. So this is like another thing. So let's say you have some games, right? So for example, to the left, like you have like these pairs, and you want to make sure like it doesn't like hit to the top pipe or bottom pipe, or to the right, you have like the Mario thing, right? And you can see like these shapes. Some of them are a square or rectangle, but some of them are also some sort of like weird images, right? They are not like circle or they are not like a triangle or rectangle, right? There are some sort of images. But what we are doing here is that we assume that the bounding box is completely around this figure, and this figure actually completely can be represented by that bounding box, right? So if those bounding box miss each other, even if visually speaking there is no collision, we assume that there is a collision because their bounding box like have some sort of like overlap with each other, right? It makes it easier for us to work with this function. Otherwise, it's going to be really difficult because we need to understand like how the shape is like how to model the shape mathematically so you can understand if there is a collision or not. So it's going to be very difficult in that case, I think. Okay, so Pooja is going to send you to the breakout room to create like a cool exercise with the same like concept, like using the collide function. So cool.
I think Nima, you might be muted.
Sorry, guys. Okay, I was muted. So this was like the exercise that you were trying to do. Like there was like the box, and then you were like to trying to catch it, and when you catch it, like you want like to create like a text that says something, right? So this is like the code that was written previously. So I'm just going to go through it with you guys just to see what's happening here. So based on like first of all, again, because like you have some sort of like a like a box, and you want like to make sure like if there's a collision, right? So you have like to create like a bounding box for that object. So let's see if I'm not sure if you can see the whole code here. So let me make it a little bit bigger. Okay, I'm going to make it bigger, maybe like this. Okay, perfect. Okay, so here we have like this draw function, right? Then you are going to use a global variable like to refer to those variables that you already defined already outside of like the function, right? You can create any background that you like. Then the field style, these things are not like the main focus here. But what we are focusing here is that if you have like the rectangle with the target X, target Y, right? And then you want to create a bounding box with the same values, right? After, of course, like you update like the target X and target Y, right? So for example, you can, based on the speed, you can like change the speed, you can change the target X. But at the end of the day, whenever like your target X is, right? Like after update, if you're updating target Y as well, if you want to, but at the end of the day, you want to use the same target X and target Y value to create your target bound, right? Here. Right. And then you have like the, like again, like a simple, like a red rectangle with a stroke style, right? And you want to create like a player bound, which is like where you want like to move, if you like to move your mouse, you want to like change the bounding box of that cursor as well, right? So you have like two bounding boxes. One of them is for the object, the other one is when you move your cursor, right? Like the mouse here. So which is like whatever values that you use here, you want to like use the same values for the bounding box. And then this is like a simple collision. So if there is a collision between those targets, right? And then you want to create like a text. So this is just a simple idea, but this is like a very complicated thing. You can like use it in a simpler way to understand it first before moving on to the more complicated project. So I think we're almost done. one of like the last thing that I want to talk about is the image. So it's not a big deal. It's like a really simple. So instead of like creating like the circle or rectangle with a circle function or rect function, you are just going to just use images. That's it. So I'm going just to do it here like this because I think we are good to go. Okay, so let's say you have different images like you found online, right? You wanna use it, right? So how can you use the images in the program? Of course, like the images can be in the background or can be object, right? So it's like a simple way to do this is using the function image, right? So what's happening here is that if you use the function image, right, you first need to tell that function what picture the function needs to use, right? Maybe you have like a lot of pictures, right? So you need to provide the image name. And then after that, it's going to be similar to a rect function. So you need the x, y, and the width and height. So it's the same. But what's happening here is that instead of creating a rectangle with x, y, w, h, it creates a somehow like a imaginary rectangle, right? So it's some sort of like a bounding box rectangle, right? And then put that image inside that. So this x, y, and w, h, you can think of it as, it's not the bounding box function, but you can think of it as the boundaries of that image, which we assume that is like a rectangle. Okay, so what's important here to know that like don't change like the width or height of the image over time. Like for example, if you want like to draw something or using a loop or condition, whatever, try to keep it as is. So I mean, of course you can move it. So we are not talking about like the movement here, but do not change like the width or height of the image. So we are going just to go through it together to see how it works. So okay. So let me show you here. So there is these two links. I think Pooja can. So Pooja, can you put them in chat so the students can go to it and download their pictures? So you can go to these pictures, go to these links and download like the pictures. So for example, in this case, there should be two pictures. One of them should be like this black one. The other one should be these things. So I did already. I have it in my download files here. So background and shape. So you should see, of course, like, let me see if Pooja already did that. Perfect. So just click on those links and then download the pictures. So you should see like two files, right? I renamed them already myself to two like sheet and background, similar to what you can see here, like sheet by background. Of course, you can name it whatever you want, but the concept is the same. So I'm going to use these files here. So let's open our window. Okay, I downloaded sheet and background. I'm going just to drag and put it here. So you can see there's a sheet png file here, and then there's a background and put it here. So what's happening here is that you are just trying to copy the file or upload the file that you have in this Ignite environment. So like the Ignite directory now understands like there are two like files in directory and you can easily use them in your code. Okay, what's happening here? Okay, it should have appeared. So I'm going just to do it again one more time. Okay. This is getting crazy. Okay, I have no idea what's happening here. Okay. I have this one here, so this should be here. You know what? I'm going just to. Oh, maybe I need to refresh it. Let's reload it one more time. Okay. Let's see if it works. That doesn't work. That's weird. I mean, that probably because I did it before and it worked, but I don't know what's happening here that it doesn't work. So maybe, I mean, that you guys can tell me if you are doing it on your end, if you have the same problem, because, okay, now finally, okay. So now I can see the background PNG. So yeah, I mean that, I think that it depends on, like, on how many people are doing the same thing, maybe on the server, or maybe there's a traffic. I have no idea what's happening behind the scene, but this should work. So I'm going back to the slides. Okay. So before, you have like this rect function or circle function to create circles or background. But here we can see that we can use the same concept for the background or the figure. So I'm going just to copy this one and copy it here. So there is one slightly different. Okay, I'm going just, let me see if I can close this one. Okay, let's see. Perfect. Okay, it's better. So previously you have like this background function, right? So you say, okay, I have background, then you have black, right, or whatever, and then you draw the background, right? But here I don't want to use background. I want to use the image, right? But since I want it to be the background, so I use the size 0, 0, 500, 500 because I want it to be like the size of my window, right, as a background, right? And then I have like the image sheep or whatever image that you like, whatever other images that you want like to put here. And then for this image, you have like to provide like the X, Y, and then the width and height, right? Of course, you can use any other values. You can say you can just put it to be fixed here. You can just say, I have 50 and 50, and that's it, right? So it becomes something like, oh, I forgot the ignite thing. Ignite. Okay. Huh. It's interesting. This is really weird. I think that the same problem that I faced before for importing that sheet PNG and background PNG. I have no idea what's happening here. Does anyone have a clue here? Because this should work, I think. So let me stop it. So let's do 6 minus 50. I'm not sure if it's necessary. Let me see. I don't think it's necessary. I can't see anything. That is weird. Okay, guys, I have no clue what's happening here because I think this should work. Pooja, do you have any idea? Because I tried before like the session, and it worked for me. Right, I saw like the picture and everything. But
I'm
I
honestly,
think, yeah.
I'm honestly not sure. The only recommendation I have is maybe restarting the kernel.
Yeah, maybe. Yeah, I have like, yeah, maybe. So maybe see if I can. Okay, so let's start from the beginning. So let me. Okay, I think I didn't import a Spark when I reload the whole page. Maybe that's the reason. So let's see. I now remember that. Maybe that was the reason because I forgot to do that. Yeah, it doesn't work. Okay, so let me see if I can restart the kernel and clear our output. Okay, so let's see. Okay, so let's do it one more time. Okay, so probably there was a problem with the kernel. So maybe this happens to you guys as well. So if that happens, just go to the kernel, just restart kernel. I usually do restart kernel and clear all outputs because I just want to see the new output myself. I just want to rerun everything. So this is just a background with the same size that I defined with a 0, 0, and 500, 500. And this is just the image that can move with my mouse. Okay. So thank you, Pooja, for the suggestion that works. Okay. So project. So we are almost done because we are not going to tell you anything new here. I mean, of course, there are a lot of things that you need to probably learn on your end, like on your own. You can just Google stuff, try to practice online, try to practice like new things, try to be creative, right? So we are almost done with the materials here. But we're going to have some sort of projects which are going to be optional, and you can earn up to 250 Ignite points, right? So we have like 5 categories here. So readability, which means that you need to make sure that your code is readable in an easy way, right? So you want to use a good name for the variable, a good name for the function, right? You want to use a space or like a blank line between blocks of code, right? For example, if you want to do something like, let's say this, so for I in range 5 and blah, 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 whatever, then whatever, right, whatever. And then you want to like, for example, undent it and then right from the beginning of the line for the rest of the code, it is better to have, for example, one blank line here, right? It's better to start here, for example, right? It gives you some sort of, it helps you like to increase like the readability of your code, right? So there are other stuff, of course. I mean, that if you Google it, you can see a lot of stuff that you can keep in mind when you want to write your code. So efficiency, right? Which means that it's better to not do something like twice or in a redundant way, right? So for example, let's say I have something like x plus 2, and then I have x times 2, right? For example, this is just a simple example. So what's happening here is that I'm adding 2 to my x, right? And then I double it, right? So why not do it, for example, at the same time? So something like that, right? So I mean, that even better than this one is maybe this one, right? You just get rid of the parentheses. So I mean, it's up to the, of course, the problem. Maybe you need to use parentheses or not. But the idea here is that you want to reduce the number of the lines of the code, right? Which also helps with the readability of the code. But at the same time, you want to do that, you want to make sure that your code is efficient, right? So the novelty is up to you guys, right? There are a lot of ways to be creative in terms of like designing, like designing like the solution, right? So there are, for example, maybe 2 or 3 ways to solve a problem or project, and it's up to you guys to decide which is better in your case. So we have like a functionality, like if it works, like something like that, and then we have like the complexity, right? So by the way, so complexity here doesn't mean that your code must show something like a complex or weird number of lines, right? Because that means your code is not readable. So complexity means that like the complexity of the project, right? If, for example, you can like your project can show different kind of stuff, right? Like the collision, maybe the change of the color, change of the like size of like a rectangle or circle, right? Different things. So we call like we mean complexity here. Okay, so there's this link here. I think all of you guys will have access to the slide. So go to this link, and then you can submit as projects you would like to the deadline, which is April 12th, midnight. So I mean, do not. I mean, that if you want to do the project, it's up to you. But if you want to do the project, try to do it slowly. And it is better, for example, after you write like a draft for your project, like maybe a piece of code, and that it works, that's okay. But like leave there for 1 or 2 days, then come back to it. Then you can see with a fresh eye, right? So maybe you see some sort of new things there. Maybe you can clean your code to make it more readable, right? Or make it more efficient. So, but if you, for example, do it all of them together, maybe in 1 or 2 days, you don't have the chance to go back to it to revise your code. So just give it like a maybe few days. It can help you a lot in terms of like modifying and making your code better. Okay, so again, we have 2 groups as before, but project Python Lava. So you have like 2 different links. So use those. And again, we have a Discord. If you have any question, I'm not sure if you're on Discord, but if you're not, you can, if for the project, you can just go there and ask questions. And like your mentors will get back to you for sure, and then they answer your questions if they can. And then if you think that your project is cool, you can just let the mentors know, and then they can help you with that, right? Maybe they can share them on the social media pages, right? Okay, so next week, as I said before, we are not going to give you any new materials. So if you are interested in programming, of course, there is nothing there to stop you. So go ahead and just Google stuff, try to do more practice. So next week, we are going to have like a Kahoot, which is like some sort of like a game. And then we're just going to review all the stuff that we learned so far. Okay. So Gala event, which is April 16, which is like about like this program. So about like the completion of this program. So you can also talk about talk with the industry speakers. I'm not sure at this moment who is coming to like this Gala this year. It seems that like I can see in the note that in the past we have like speakers from Google, Microsoft, and Intel. Cool. So I'm not sure if you have the same thing. I mean, if you have like the same speakers, or even like some of them would be really cool, you guys. So I encourage you to attend. You have like the registration link here, so make sure to go through that. And we're going to have exercises. So I think that right now we are at the end of our session. I'm going to see you next week for the last time, but for now, I think Pooja is going to send you to the breakout room for exercises, right, Pooja? Okay.
Yes.
Okay. So see you, I don't know, in 10 or 15 minutes, 20 minutes.